And we're live. Hi, everyone. Welcome to this week's on .NET Live. My name is Cecil Philip. And in today's show, we're going to learn all about how we can build GraphQL APIs with a really cool project called Hot Chocolate. And I have my friend Michael here with me. He's going to tell us all about it. So, Michael, why don't we start off with you just introducing yourself really quickly and letting folks know who you are, where you're from, and like, what do you do?
Yeah, thank you, Cecil. I'm Michael Staib. I'm a Microsoft MVP. And I'm one of the authors of the Hot Chocolate GraphQL library for .NET. So I'm dealing with GraphQL on a daily basis. And I'm doing that, I think, for the last 3 years almost, or a bit longer maybe.
Nice, nice. And so we're going to dive into like what is GraphQL and how we can get started with some of these things using like Blazor and ASP.NET in the backend. But first, I want to go through a few quick announcements that I think will be really exciting to share with folks. So what I'm going to do, I'm going to swap over and I'm going to share my screen really quickly. And we're going to take a look at some of these things. And I think my screen's sharing. There we go. All right. So first announcement that I want to make today, some of you may or may not have heard this, but yesterday, Dapper, the distributed application runtime, our open source project for creating microservice-like applications went V1 officially yesterday. So for those of you that are interested in building microservices and having some built-in conventions and patterns, this is a really great project for you to check out. Head over to their blog post site. I'll share this link in the chat, but this is a really good blog post that talks about some of the folks that are using Dapper, some of the scenarios it covers, and some of the big features that you should really pay attention to for V1. So definitely go ahead and check that out if you're interested in building like some microservice-y things. Another thing that came out yesterday as well, yesterday seemed to be like a big day for announcements. Another thing that came out yesterday was preview 1 of .NET 6. I'm really excited for this one, particularly for the Blazor stuff that they have going on. So if you scroll down and you check out some of the things that are released inside of this first preview, you can see them talking about things like .NET MAUI, Blazor desktop apps, and then there's even some mentions of some micro API things that they're planning for ASP.NET Core. So really interested to hear about that and seeing how that progresses as we're on the road to .NET 6 right now. And last thing I want to mention super quick, .NET Conf focus on Windows. This is happening next week, February 25th. And just like some of our other focus events for .NET Conf, this is going to be primarily focused on Windows. So it's going to be like those really short, 30, 25-minute sessions featuring folks from the community. It's all live, it's all free, and all you got to do is kind of just head over to this website and just show up. Like, you don't have to register or anything like that, which I think is be great. So again, this is .NET Conf focus on Windows. Again, if you're interested in learning about building desktop apps with UWP, WPF, WinForms, and other things, this will be definitely something great for you to check out. And with that, I think that's about it for my updates for today. I'm going to stop sharing my screen. Michael, what did you think about some of those announcements, man? Like,
It's great
that you're looking forward to for .NET 6?
Yeah, I'm really psyched about the Blazor stuff, and that they are finally moving to the desktop, so you can reuse all the knowledge that you acquired starting in the server, then you moved into the browser with the WebAssembly stuff, and now you finally go on full circle onto the desktop. So I'm really looking forward to that.
Yeah, I think it's a really interesting use case where you could reuse like your web skills and build all different types of applications with them, from like web to mobile to browser-based things. I think it's good for us to be lazy developers a little bit, right, and kind of rinse and repeat our code around the place. So I think that's really cool.
Yeah, and I think that was really missing from the .NET platform, to have something like we had in JavaScript. We have React and React Native, but this full circle framework was missing from .NET so far. That's really great that they finally got around to do it.
Yeah, for sure, for sure. And speaking about Blazor too, I know we're going to talk about some Blazor things when we start diving into hot chocolate and some of the updates you have to share. But
yes.
I kind of want to start off with asking a question. I'm pretty sure you've heard this question a lot, but in 2020, why is it that people care so much about GraphQL? Like, what is so special about this new way of building APIs that's really attracting developers to use it?
I think it resolves a lot of friction that you had with fetching data. So if you think about traditional technologies like RPC, SOAP, or REST, it was always that the backend developer really planned ahead of time what the front-end developers should be able to use. So all the requests that you were to use as a front-end developers were planned and already there. And as your screen size changed or your use cases changed for your multiple applications, your demands really changed. And with those pre-planned APIs, you kind of were stuck in those cycles. Okay, I have now a changed use case, or I have a different device now, so I have to go back to the backend developer, ask for changes, and then you have all those full cycles and misunderstandings. So with GraphQL, we finally changed that, and we changed the perspective that you had as a front-end developer, that you could craft your own requests, ask for the data you need. And I think that resonates with a lot of developers. And it's not only a great thing for front-end developers, it's also a great thing for the backend developer, because the backend developer can finally really mold with a strong set of APIs that is enforced by a strong execution engine, how the front-end developer really can explore the data. So I think these data graphs offer a lot of opportunity for the developer community, and that is why they really attract so much people. And especially in .NET, we are getting more and more of those features that JavaScript developers already had for a long time. I mean, if we look at what we have in the Node ecosystem, we only catched up, I would say, in 2020 to the feature set that they had. So for us .NET developers, 2020 was a great year with GraphQL.
Nice. And we're really glad that you're here to work on this project with us. One of the things that I kind of think about when I hear people talk about GraphQL is, it gives us the option to kind of control the story of our schema a little bit more from the client perspective. But even from a backend perspective too, it also allows us to bring together a lot of different sources of information, right? So I can connect directly to databases, or I can connect to other GraphQL things or other sources of information, which I think is great, because often we hear the story that GraphQL is like a replacement for HTTP APIs. But as I look into it a little bit more, I kind of feel like it's a companion. Like we use them together, we can build on top of each other to make like a really cool experience. Would you agree with that?
Yes. So if you look, for instance, at Facebook, and Facebook is the inventor of GraphQL, as the most people know, they internally use GraphQL. But externally, they actually use something called the Facebook Graph, which is their REST API. And there are other companies like GitHub, which use their V3 API is REST, and they have additionally a public API that is GraphQL. Right. So if you can, I would always suggest to cater multiple needs. And GraphQL is a great thing for that, because you might have started with your set of REST APIs or OData APIs, and then you build over these your new GraphQL API, and essentially start with the set of REST APIs or other technology that you have, and build over that this nice layer of GraphQL APIs.
Right. And I just want to look in the chat here really quickly. And coming in from YouTube, we have Rick the Clipper. And Rick is saying, Michael, may I suggest that you focus on the benefits of GraphQL in a third world internet as we have in Germany? And I guess he's kind of talking about some of the performance benefits that you can get from GraphQL, right? Because you can control the payload, so to speak. You can really optimize like some of those messages that are going back and forth.
Yes, that is definitely actually where GraphQL came from. So originally Facebook, back in 2012, when they first introduced GraphQL internally, they started to work on that, especially because of those things. So essentially, GraphQL was developed for mobile applications, for Facebook's set of mobile applications that really performed very badly back in the day. So GraphQL, because you can pick and choose your requests, because you can ask the server for what you want, you can optimize your request, and you don't have those problems for overfetching or underfetching, where you pull in too much data because one of the REST APIs that is there just forces you to consume more data than you need. I assumed most people here are already familiar with this concept of GraphQL, but it came originally from the way to optimize data request or fetching data. But I think today it's not only about optimizing your communication and reducing those requests that you have. It's also about that you can put a lot of aggregation logic into the server, and also that you have this strong, predictable data graph that you can query into. And it's really a joy when you start the first time with GraphQL and you start consuming data through GraphQL, how you can drill into the graph, how you can explore the data that a backend offers to you. So it's not only the benefits of fetching data more efficiently, it's also how you can explore the data and what guarantees the server really offers to you. So from a predictability standpoint.
And I know with GraphQL, it's like you said, it's more than just querying data, but there's also things like subscriptions and real-time communication and mutations. And like there's tons more than just, I want to aggregate some information and like pull it back in an interesting way, right?
Exactly. And we will dig into a ton of these things. And also from a Blazor perspective, because I think that is where we can offer with the next release of Strawberry Shake a lot of benefits that we haven't had in the .NET community so far.
So I got to ask you this. I have to, right? The name of the project is Hot Chocolate. You have another project called Strawberry Shortcake for Blazor, and you also have Banana Cake Pop. Like, where do you get these names from? Like, where do you get the inspiration to name your projects after food?
So actually, it all started with hot chocolate, which we had kind of a stupid name in the beginning. I don't know anymore how we called it.
Yeah.
But maybe if you go into our first commit on GitHub, you see it.
Yeah.
Okay. So my brother was standing kind of in Starbucks, and because my son was back then, I think 3 years old, and he always wanted a hot chocolate when he's in Starbucks. And so my brother said, let's call it hot chocolate. It's a funny name, and will stand out more than just naming it in GraphQL or GraphQL.net.
Nice. I love it, man. And I'm sure everyone appreciates like the names too. Like it's really cool. Why don't we kind of dive into some of the updates that you came in to talk about today? Why don't we start with like let's start from the front and go backwards, right? So how about we start with some Blazor stuff and talk about how we could start consuming GraphQL endpoints from Blazor, and then we'll dive into the server.
That's awesome, because I think the most you appreciate GraphQL is when you really consume it. And that's why it's actually cool to start from the front end and really explore what the benefits for the consumer GraphQL offers. And then you see all the benefits for fetching data in a much different way than before.
Sure.
So can we share my screen?
Yep, screen's up.
Awesome.
There we go.
So let's start on the console. We start with Visual Studio Code. I have lots of IDEs today. But let's start with my favorite one. And let's really head in. So this is a simple Blazor example. It's an example that I actually showed off in a lot of talks when I talked about previews of Strawberry Shake. But now we see really all the work that came together since the last preview in August.
Okay.
And I think this will really bring a lot of benefits from the JavaScript world into the .NET ecosystem. So first, let's just run our little shell here to see what we are up to. So this is an empty chat application. What we are building is essentially a Slack clone, not so fancy like Slack, but a little bit.
So you mean I can't start a new business like a Slack competitor using this demo?
Or Teams competitor? We don't know. Yeah, no, I'm not that good with design, and it's not as feature rich as both of these products. But let's just try to build something fun. And all of you can help me later. You can send in messages when we are a bit further along with that. So we have a welcome screen, and I just introduced that today to show off a very cool feature later. So it's kind of dumb now, but it will make sense later. So essentially we have a welcome screen. We can go to our chat, which is empty, because we are going to build that together. Okay, so this essentially will be our shell. It's nothing in there yet, and we will build that all together. So how do we start with GraphQL? Or how do we start with such an application? So the first thing is we need kind of a model to work with. And to explore the model, we actually could pick one GraphQL IDE and first look at the server, what data the server offers to us. So in this instance, I'm using Banana Cake Pop. That's our GraphQL IDE. And I'm going to my demo server here. That's my chat server. And we can essentially look at our schema. So what do we need for a chat app? If we look at something like Slack, let me bring that up here. Oh yeah, coming up. We always have this sidebar where we have interaction with others. We have channels, and maybe we have users that we can talk to. And then we have this middle area where we have all the interaction. We have a chat, we have essentially a message window where we can type our message, and we have all this message streams that we can listen into. So the first thing we want to do is essentially just build out the left-hand sidebar where we have all the users we can chat to. So we have a couple of ways to do that. We could either go to the currently logged in user here, me, and query it for all of the friends this person has, and then could drill into this nodes field here, which offers all the persons that I have. This nodes field here is part of a paging API, a cursor-based pagination. We will not go into that so much today, but just that you know that it's because of a paging API that it's called like that. Okay, there are other things. We could also directly query all the people on the server. And we essentially could drill in here into our nodes field directly and get the same thing that we could get through the logged-in user. We also could grab other users from the server and drill in the same way. So what we will do is just grab this people field here and drill from there in to get our data. So how do we write GraphQL queries in our Visual Studio Code client? So the first thing is we need a tool. And this tool, I just restore it, is the Strawberry Shake tools, and it integrates with the .NET console. So we do .NET tool restore. I pre-installed that. So I'm using here a preview 57. We already have a preview 58 online. So if you want to try that out, you can do that with the newer preview. Okay, so I've restored that. And now I have a new command here that is called .NET GraphQL init. And I essentially can grab a GraphQL. Just let me get back to my URL here. Grab that, put that in. So I essentially can put in a GraphQL URL here, and then say I want to name my client a specific way, for instance, chat client. And then I hit enter. And what happens now is that we are creating a GraphQL config here, and we are also creating a schema here and a schema extension files here. I'll walk you through these in a bit. So the GraphQL config file just describes, okay, there's a schema file here, and then there are lots of GraphQL documents. You could specify a filter or a list of filters here to define where GraphQL files really lie. So for us, this glob here is sufficient because it will cover all the GraphQL files that we have somewhere here. We also have a refetch URL and some generation options here to generate also dependency injection code and stuff like that. Okay, so the next thing is that we want to start writing code. So we go into here and create a new file. For instance, we want to grab all the people we can chat to. So we create a new file called get_users.graphql. Okay, and in here we can start writing our GraphQL query. We could start, for instance, by saying we want to do a query, so the keyword query, then get users. And then we could look at all the things we could query. And you can see here the IntelliSense already popping up. And that's because of our GraphQL configuration that we have here and the schema file that we downloaded. So Visual Studio Code now has all the information about how what our graph exposes. So I don't need to go to Banana Cake Pop to write my query. I can just do it here.
Oh, that's really cool. So is that because of that GraphQL rc.json file that you generated?
Yes. So we are integrating with these standardized configuration in the GraphQL environment. And we actually installed the GraphQL Foundation extension here. And that just picks up now this standardized way to define GraphQL queries. It's essentially the same way the JavaScript environment does it. So everything that you use in JavaScript, in your JavaScript development, will work with our tooling.
Nice.
And that is really nice. For Visual Studio, we are working to bring Banana Cake Pop into Visual Studio. So because that doesn't have good tooling at the moment, We're working to get Banana Cake Pop in there, and we are also working to get it into Visual Studio for Mac. It's not in there yet, so we are still working through getting this new release out. But for Visual Studio Code, it's already awesome because GraphQL Foundation already has a nice plugin for us that we can just hook into. Okay, so let's write our query. We have this people field that we want to grab and want to get into. And we are grabbing the nodes, which essentially are all the people that we want to grab. So what we can do here is pick all the fields that we need. And I know already the fields I want to have for my component. It's essentially the ID, the name, the email. Well, actually, we don't need the ID. We just need the name and the email in my example. And then we need an image UI. If the user has an image, we want to show it. We need the last seen. And we need the is online status. So if the user is online or not. Okay, this should be sufficient for our first request and for a component that we have. But we actually want to do something else here. To have a nicer C# type, we want to actually use fragments to define more how our classes are shaped. So fragments are essentially our primitive for composition in GraphQL, and we can essentially generate from these nice C# files. So classes, interfaces, and stuff. So we are creating this fragment here. And we are calling it a user. And we are applying that on a person. Because our type actually is a person in the server, but in our domain, in our problem domain, we call it the user. So what we are putting in here are these fields.
Oh, okay. So then would you say that fragments, I'm just trying to put it into other words, would fragments are pretty much just ways that we could shape the data from the source? So let's say person was an entity framework thing, right? Like user could be the shape of the data that we want to have returned from GraphQL.
Yes, it's essentially like that. So user, so we could also reuse the words, and I will use the words entities in a bit, because essentially person is an entity in the backend, and user is just a view on this entity, a specific view on this entity. And we will even shape that further as we build out our component here. So, but let's start with this very simple thing. And let's just compile that. And now source generator kicks in. So all this is built with source generator. We specified. Okay. So there are still tiny issues. So usually we should infer from the project, the namespace. With Blazor projects, we still sometimes have a problem. So we can also override the namespace here. Let me just grab the namespace. What is, okay, we call it demo. So let's put that in here.
And then while you're doing that, we got a couple questions that are popping in on chat, and I want to make sure that we jump on some of these before.
Yes.
So one question we had come in says, I'm a newbie in GraphQL. Is GraphQL Hot Chocolate implementation connectable with Entity Framework Core?
Yes, it is, and we'll see that later when we build our server. We actually use Entity Framework Core, but it's also working with Entity Framework, and there is a new integration coming with the 11.1 release, so it works natively with MongoDB, and not over iQueryable, but over the native query language. And there are more things coming, like Elasticsearch support and other data sources within your releases.
Awesome, cool.
But we'll look at that as specifically at Entity Framework in our server demos.
Got it.
Okay, so now we generated all the things that we needed. We actually have now here generated code that represents all the client code that we have. We just put it here. So actually we are using source generators, but many of the IDEs have the problems to read the generated source from the in-memory workspace representation. So what we figured is to just put it somewhere. You can switch that off if your IDE supports reading it from the in-memory workspace of Roslyn. If not, you have just for the IDE some kind of a code representation here. You can look at the code, you can debug and through the code, so it's just for help. So actually underneath, it's directly injected into Roslyn. Okay, so with that, we have some generated code here. Let's have a look at our components. So actually our Blazor application, let's have a look at our router here, has 2 pages. So in the router, we have just set up some basic things. So that is actually when you create the default application, you will end up, I think, probably with the same router here. So what we then have are 2 pages. One is the index page, which just has a link to go to the actual chat client. And then we have the chat client, which only has a component main in here. The main component at the moment is completely empty. So in Blazor or in SPA applications, we actually have this concept of smart and dumb components. Or you could say about these stateful and stateless components. So essentially what we do is aggregate data, or we have all the interaction with our data sources in the stateful components. These stateful components press the data down the component tree. And if the stateless components that are further down the component tree want to interact with data, they do it through events. We will see how that works in a bit. So our main component is for us our smart component where all the magic will happen. Then we have here 2 categories of, I would call them dumb components. You could also divide that up differently. You could have multiple stateful components. It depends a bit on your layout. Okay, so let me just enable this set that represents our user list and walk you through that. So the people list is essentially our root component here that we will put directly into our main component. It at the moment has here some code that if this component is loading, it will put some placeholders in. It also has an understanding of what a user is, and actually this user is some of our generated code. So we don't have to do anything. We just created our GraphQL query, and we already have the user type that I need for my component. Okay, let me go back. I also have a callback here. So if I click on a person, I will get an event that I can catch in my main component and then do something with it.
Nice. Okay. So pretty much it looks at those, that file that you essentially wrote, that GraphQL file, and it generated all these things for us.
Yes. Right. So essentially we generated all the client entities for you, or actually these are just our models, but it generated entities. We will look what entities really mean in that context as we build our first request in. Because there are some nice concepts around that. But it generates all these types and all these views on the data. And we can just use it in our components. We could even say that we are writing our GraphQL queries especially for our components, so that they fit our components and just fetch the data we need for our components. And that's essentially what we did with our fragment. It was essentially written to fit this component. So we have all the data to fulfill this component. So what we are doing here is when we have users, we essentially iterate over them and then create more components, this person component here, which essentially then displays a user. And you can see it takes from the user the state, it uses the field is online, it uses the name, all the things that I define actually in my GraphQL query are used in that component. You can see that there's a name, there's the is online we used here. We have the last seen date. So all the data we are using out of this fragment. So this fragment is actually the input for this component. Okay.
So quick question for you then. So as someone that hasn't used GraphQL a lot, I'm kind of wondering who's responsible for creating these things. So is it the job of the GraphQL server side to provide these fragments, or is the client the one that generates these fragments and now consuming these things on the client side, or does it not matter?
So these fragments or this query document is written by the consumer of the GraphQL endpoint and is written for a specific use case. You can we will do that in the second part. We will build out more fragments that interconnect, and then really see how powerful these things is. So this is what the user writes. So essentially, you are writing your own interface between the backend and your client application. This all will become our interface between our backend and our client. And it also defines the shapes that we want to use in our components.
Yeah, so it's almost like the client is creating its own API client, essentially.
Exactly, yes.
Like these are the types that I want to consume, and this is how I want to consume them. And so I'll define that, and I'll point that towards that GraphQL endpoint, and then it'll generate these types for me that I could start using inside my application.
That's exactly, and that's exactly what I mean with it removes the data, the friction of fetching data now. Because with REST, we would have to take what is there or go to the backend developer and ask for the specific request just for our client, which the backend developers most often don't want to give us. But now I can craft that exactly how I need it. And that's the power of GraphQL.
Cool. All right, that makes sense.
Okay, so we have built that in, and that works now, kind of. And now we need to connect to our client, really. So let me just put in some imports for new components that we have there. So I go to this imports razor, and that's where essentially you can put in the commonly used namespaces that you use throughout your application. So I'm putting people in here so that I don't have any usings in my main component. And now I essentially could put in my main component, my people list component here. Okay. But I need some inputs for this component. Let's put this people list component on this side and have a look at all the parameters that we have here. So we have is loading indicator that essentially is used to define if our component is still loading data or not. We have our click user here, which is an event we need to consume. And we have our list of users. So how do we get that? So in order to use our GraphQL client, we need to inject it. So we can kind of say inject. We call it a chat client. And let's put a variable chat client here. So essentially, we are injecting the chat client into the variable chat client here. And now we can kind of query data from it. So what we are used to in the .NET world is to essentially do an execute and fetch that. But we looked a lot at the JavaScript worlds, JavaScript applications, and how they actually fetch data. And more often, you actually don't want to just fetch data. You want to kind of watch data. So we put a watch in here. And then we kind of subscribe onto that.
Hold on. So you're telling me on the client side, essentially I'm doing like a publish subscribe. So I'm listening to some query endpoint, and as data changes or gets updated, it gets pushed to me. Is that what's happening here?
Kind of. So what Strawberry Shake is not just a client. It's also a store for your state. And what this can do, we will see. So the cool thing here is this fully integrates with a system reactive. So all the nice work that Microsoft did around system reactive can be used here. So you can replay those changes and you can listen to changes of your entities. So we are actually listening to changes to the entities of the user, or not of the user. The user is just our shape. But we are actually listening to, or we are asking for data, and then we are listening to changes on this people entity. So let's see what that actually means. So what we get here is we watch our store, and then we get result whenever this result changes. And this is essentially a standard GraphQL result that we also get with the execute. But we always get it when it changes, or when one of the entities in this result tree changes. Okay, so let's grab the people field that we actually consume and get all the nodes and put the nodes maybe on a little field here. So we need an I-read-only list, I think, of users. And let's do it. Let's let it be an empty array at the beginning. And as soon as we have data, it will be updated by this. So, and whenever we update, we actually signal to Blazor that our state has changed. And that will cause the components to re-render. So the second thing we need is the isLoading indicator. So we have here a bool, which is loading, and that is true. And when we essentially have the first set of data, we can set it to false, so we are not anymore loading. And this we can essentially set into here. We call it users is equals our users, and isLoading is our isLoading. Oh, sorry. And then we have also our click user, which essentially is our event that we want to raise. So we have maybe private async task on click user, which has an I. User as an input, that is our client object that we want to do something with whenever somebody clicks on that. Okay. So for now, we don't put anything down there. We just keep it and be happy. So this should already be working. We just have to set up some dependency injection magic in our program CS. So essentially in Blazor, you can set up all the services that you need in your program CS. So we go in here, go to the builder, say we need the services. We say add chat client, and all the dependency injection code is generated for us by our source generator.
That's really cool. I like that.
So it integrates neatly with all the other services. So the next thing is we need a transport. So let's put in an HTTP client, services, add HTTP client. You can see I already cheated a bit. So up there, we have a token that I just put statically in there, but it is enough for our little demo here. So then we say, okay, we have a client. Let's put that just together. And then we can explore the interesting stuff. New UI. That's where we put our UI. And default request headers, authorization, put our error token, and let's see token we have up there. Okay, so let me just grab our GraphQL URI here. And let's run that.
Okay, so it's running.
Yes.
And
so let's go to Microsoft Edge here. Just paste it in. We get to our empty page. Then we can go here and we already get our data. So what I want to show you here, so that's simple. Nothing changes. It's essentially what we get with execute. So let's have a look at the developer tools here and at our console. So at the moment, this is not an optimized behavior. So if we go back and go back to chat, we can see that every time we are going here, we are essentially doing an HTTP request. But I talked about stores and about state and about this watch. So what does it mean? So if you go here to main, we can define the watch behavior. So we could say we have a different execution strategy, and our execution strategy is to use the cache first. That means every time we go here and watch for changes on our store, we first look in the store. And if there is something in the store, we will take that. If there's nothing in the store, we will fetch from the server and populate the store and then trigger our subscribe here. But there's more to that.
Right, and then I'm guessing the store just keeps everything in memory, right? Or can you also specify where it caches that stuff? Like say, put it in local storage or put it in a certain.
You can also persist your store, and that's where we go into optimistic mutations and stuff like that. Where you essentially serialize the store because these entities that we store in there are serializable. They are normalized. So we are essentially taking the graph and cutting it down in entities. So let me go to this slide. So how that works is essentially when we get a response here like this, this response is actually in this shape here, we have 3 entities. We will cut it down in 3 entities, store them in the entity store. But we also will store the operation or the full operation result in the operation store. And we essentially build the operation that we are using, or the operation result that we are using in the client from these entities. So whenever one of these entities changes, we update the operation result, and that is when the subscribe is triggered. So when new entities update, essentially every time any request fetches one of the entities that the other request fetches. As we build more requests into our client, we are fetching maybe different parts of or different shapes of our entities. And then these entities update. So this means when we build in later the subscription where our messages come in that might transport, for instance, the username, if the username changes and the message comes in, all the components that use a message, the username, will automatically update, although they are listening to completely different requests. And this makes possible to build much more dynamic applications than before, because you're essentially watching a single store where we update the data in there from different requests that we write.
Got it. Okay.
Okay. So
now we got the client side set up, right? We got the store set up. We have Strawberry Shortcake is pulling in our information from our GraphQL server, wherever it's listed right now.
Yeah. So Essentially, what we now did, even our store is generated. We don't have to care about that. We don't even talk to a store. We don't actually see that there is a store. We just subscribe to our client, and beneath there sits a store that tracks all the changes, keeps track of when data is changed and when we have to be notified, when our components have to be updated. This is all nice and transparent to us.
Yeah. So I can't help but notice, like when you hovered over that watch method just now, you're using an IObservable. So does that mean that there's some reactive extensions things happening in the background?
Yeah. So actually, just like that, you don't need system reactive. We have actually an extension method here, but we in this demo are using system reactive extensions. So you could do things like you could listen for a certain result that maybe, I don't know.
You're saying you implemented these and these are not in system?
No, this is system reactive. This is system reactive.
Okay.
You don't have to use system reactive. That is what I mean. So if you just used these two messages, watch and subscribe, we have them in the package. But if you have system reactive, because system reactive lives in the system namespace, it will just swap out our extension method, and then you have the full power of system reactive here.
Got it. Awesome. So we got a quick question in the chat. I want to make sure we don't forget the chat, folks. And this person is asking, Michael, how is the documentation for V11 coming? So I know you're working on V11.1 right now.
V11.1. So we are constantly working on the documentation, and it's getting progressively better over time. But there is a lot still to do. I know there is a lot about filtering to do. It's an endless task.
Yeah. Do you have like, I know the documentation's on GitHub, right? I'm guessing it's all open source. So if folks are interested in assisting with writing documentation and samples and those types of things, I'm pretty sure they could create, a PR or something like that and kind of help out with those types of things.
Yes, I mean, we are super open for help. It's all open source, and all the folks that are working on that are really doing it mostly in their free time. There are some companies that sponsor people who work on that, but mostly people or the core contributors are all doing that in their free time.
Yeah. We got one more question I want to get to before we move on. And this person's asking, if the store is in memory, how does it behave in a load balanced environment?
So this is a client application. There is no load balancing in the client. So you have a state in your client. And the important thing is, and as we go further into it, you essentially can bring into the store not only the GraphQL, you essentially can extend your schema locally and write local resolvers to bring more data in. So you can access your whole state through that. But it's in your client session. It's a user client session. So it has nothing to do with load balancing.
So I guess as I'm reading the question, I'm guessing the person means if you have multiple front-end servers that are behind like a proxy of some sort that does round robin or something like that, how does that work? But like you said, like it's in your session, right? So if caching is a concern from a performance perspective, I'm sure you could do something like turn on like sticky sessions or something like that, so that the requests always go to the same machine, or if you needed to do those type of things, kind of like what we do with SignalR, for instance.
Yeah. So just to make clear, this is Blazor for WebAssembly running in the browser. It's not Blazor in the backend, which would have still the same thing, because we would run in the user session with all the state.
That's true.
But this is essentially a local state. So we are not talking about state in the server. There are other concerns involved.
Yeah, you're right. That's true. Okay.
So the question there, when can we expect Strawberry Shake documentation? Very soon. I will follow up with a blog post, I think, over the weekend of this new version. And then I know one of the core contributors, Fred, is already working also on a lot of documentation. We have a lot of design documents that we will publish soon.
Oh, great. Yeah, we got a lot of good
Okay.
content coming up.
Yeah. So just let me restart, because I don't know if I actually restarted it when we changed. So we have cache first here. And what that means is essentially, let me go back here. Let's refresh that. So we get our new client in here. So if we go here, you can see HTTP request is done. So if we go back and do that again, nothing happens, because now our store is filled and we set cache first. So if the cache is filled, we only consume the data that is in our client store. So as I said, this data can be updated through other requests that fetch the same data, so from the server entity. So if I now get a message that has a recipient on it, then I get my store updated here. So if I get a message in and I'm not anymore Michael Staib, but M Staib, then also my data here changes, not only in the message. Okay. Let's go on. So we have our simple thing here. It's working. It's nice. But we need a lot of stuff here in the middle. So what kind of requests do we need to fulfill our chat client? So first, we need a request that fetches the messages. So if we click on a person, we want to see the messages to that person. The next thing is we saw this message area down here in Slack. So we need some kind of a way to write a message. So 2 requests. And last but not least, we need a live stream of messages coming in as we receive messages, hopefully from one of you guys later. So we need 3 kind of requests. So let's head back into our query documents and build some more query documents. So let's just create a new query document and call it get messages. And the nice thing, let's just move it down here. And the nice thing is that we can actually use everything out of this document. So all the fragments that I have here, I can share. Essentially, what we do is we merge these documents and then split them apart however they are most efficient to send to the server. So although you can write multiple documents, you can use all the fragments of the other documents. So let's pull that next to this and start writing our query. So get messages is the operation that we want to have. Get messages. And we actually want to pass something into that. And GraphQL has a concept of variables. And that is essentially translates to parameters in C#. So you could see that that is our method. Our method get users, our method get messages. So we can put in the variable email, that is essentially the identifier by which we want to fetch our messages. So we say this is a string, it's non-nullable, and then we can start on fetching data. So we can select the person from which we want to have the messages by email. Yeah. This guy. Okay. And then essentially, we actually don't want the person. We actually want just the messages. Okay. And again, we take the notes field here. And then we can see this is actually a message that we want to fetch. Again, we take a fragment and describe how our message looks like in our user domain. So we do a message on a message. Looks a bit funny, but you will see why it's useful. So what we want here is maybe the ID. We want the direction. We want the recipient. We want the sender. We want the send date, and we want text. So what we can see here that actually recipient is a person, but we don't want to have all the data of the person. We actually just want a subset. And we call this subset a participant. So this is a different shape of the user we want to look at. So it's actually just these three fields. And because we have now this nice fragment here, we can actually tell our user fragment to use the participant fragment. Let's reformat that. And then we can actually use the participant fragment it's already showing me that participant fragment here. So it knows that we're merging these documents. So I can use it for recipient and participant. And then I'm also using it up here. So I have a nice data graph. So I actually could just compile that stuff and get already my next set of generated. You see there's more code coming in. And if I now go to our user, this guy here, I can see that user now doesn't have all the fields anymore. It just has the fields that we specifically defined here. And then it implements a participant, which has the other fields down here. So now my user is usable in all places where I actually want to use participant in my component. And I really have this control over the generated API that I have. So with GraphQL and these fragments, I really can control how my models in the client are generated. Okay, so this is 2 requests. I said we need 3 requests. So let's just duplicate this and say we need a send message. That is my next request. And it essentially is a mutation. We call it send message. And this also has 2 variables here, email, which is a string, and it has a message or text. Let's call it text, which is also a string. I hope you can all follow. And essentially, we are using the send message mutation here, which has an input. And the input gets the recipient email or email that we want to pass in, and the text that we want to write to that user. Okay, is that correct? Yes. Okay. Okay, and then this is again a message. So I can reuse my message fragment here, like I did before. Let me get that here.
And one thing I'm wondering too is that even though you're defining this mutation inside of the GraphQL schema, you still have to have like a server-side component to process that, right? Like there's still some server-side thing called send message mutation that's receiving this and doing stuff with it.
So essentially that is GraphQL query, and in my backend I just have the type system. So the execution engine knows how to execute those queries. So it's essentially that is the execution engine in GraphQL. So if we look at, this is the backend. So I have the backend schema here. And I can see here's the mutation. So that is the keyword indicator here. We have the name send message. That is just a name I can give it to identify it. And then we have here the actual mutation. And this actual mutation is in the backend here. So I'm just executing. I'm selecting it to be executed. So in the backend, there is a mutation type, and that mutation type has a send message method on it, and that is invoked.
Oh, okay. I got it. So you're not defining the mutation. You're just calling
I'm just
the mutation.
Yeah, so with GraphQL, it's not like SQL where you craft joins and stuff like that. You're more, I would say, and it's also called in the spec like that. So that is a field selection. So you're selecting things that you want to use. And you just can select more or less from the server. And that essentially gives you the power to craft the interface in the way that you want to have it. And these fragments are also essentially just a way to compose what data you want to use. So essentially to select the data that you want to use from that specific type in the server. So there's a message type in the server, and this message type, so this name, the first is living in our client, and this is essentially what we are selecting from in the server. So it's pretty easy when you get started with GraphQL, and you quickly get into how that essentially works. So it's just selecting. It's just selecting, as if you just write selects in an SQL statement. You're just selecting fields. Okay, so we now wrote the mutation that we want to have. And we essentially sent in the message that we want to produce. And then we get returned the new message object that the server produced. And that essentially is the same message shape that we used in getMessage. So both will project onto our iMessage interface in our client. Okay, so now the last thing is real-time data, and it's as easy as writing a mutation, because let's just copy that so I don't have to rename something. Let's call it read messages, because this is our way to read the message stream. And in subscription, we don't write any other like any other query. We just start with subscription. And this is selecting the real-time type in our server. So we call it read messages. The server already knows from the token who we are, so we don't have to explain or pass in any arguments here. So it just sends us the message that we receive. So we say receive, on message receive, and we can see here that this on message receive event is a message. So we essentially can just do that and be done with it. Let's make our API shape a bit more nice. So we could maybe use an alias here, message, so we get a field message on our response. Okay. With that, let's generate that. I actually never tried if aliases work with our new version, but we will find out soon enough. Okay, so our message type, look at that. Lots of types produced, but this is actually the type one. Is our message type. You can see it's actually using here a unique type, which is a participant. So each message has a participant, and that's actually what we defined. Okay. So let's head into our component and put that all together. So first, let's uncomment our message components here and recompile. And then
you've written like a bash script that would like just go ahead and rename
yes.
this stuff here.
Yeah, but to be honest, I just built this demo, or re-engineered this demo yesterday. So it's pretty fresh. So we have participant does not contain a definition for is online. So let's have a look if we did something wrong with our participant interface. So get users, participant, oh yes. So I swapped the fields. This goes here, and we actually need this here. And then let's regenerate. And the nice thing is, with source generators, we have all this compilation. We have all this compilation niceness. So if I do a mistake here, you can already, I get a squiggle here already from our GraphQL tools. But if I compile that, I actually get a proper compile error here. That something is wrong. So I get multiple compile errors. But I should. This is just from our Razor components. We don't have any thing. Yeah, but I also have here a compile error from my get users, and I can head into it and fix that. So that is all provided by the Roslyn diagnostics. And makes it pretty powerful. It works in Visual Studio even without all the tooling. Just recompile that. Is it correct? UI. And it works in any IDE. So that's pretty cool with now the source generators in place.
Okay. So now after you've built this, we should see those messages show up inside of the chat window?
Yes, so we now have this participant here, so we can see all the stuff should now comes together. So it works now. Let's put that whole thing together and see that it all works. So what we have here now is basically the people list. We're putting the next to the message list in here. Before I actually do that, let me just, you can see it wants to put this ugly long string in here. So let's go to our imports. And we want also the chat namespace to be imported. So we get a nicer component name. Okay. So we have the message list in here. And our message list actually has also some inputs that it wants. So let's have a look at the message parameters. And the message parameters here, I have a click send when I send my message. I have it is loading. We already have that. I need a recipient. That is the person I want to write to. And I need an immutable list of messages. Okay, let's put that in and then bind that to our component. And we can just steal that here. And at the beginning, it's just an empty immutable list, I would say. Empty immutable list of iMessage. It's empty. And we have this recipient object which is an iUser recipient, which also is kind of nullable. We didn't have nullable turned on, so I did it for nothing. Okay, so with this, we can bind everything to our message list here. And so it's loading. We actually can copy that from here. Then we have, we say messages. This binds to our add messages. Then we have the recipient, which binds to our add recipient. And then we have this event, which is click send, which will bind to on click send. Okay, so this, let's create that. Okay, there's no shortcut for it. So let's copy that. On click send, which gets a string in there, a string which is our text, our message text. And now let's put it together with the client. So what we need to do now is, so when we click on the user, we essentially need to fetch the messages. So we can do that here. Chat client, get messages, and execute that. In this instance, we just use a simple execute to fetch the data. We don't watch the data. We just fetch it. It still will update the store. So in this case, we are using the email here. Wait, we get a result here. And this is the same result we would get in the subscribe method here. So we just grab that. And then we put that into our messages. So we say messages. And this is a create range here. And then we just put in the data of our request. So data, person by email, messages, and notes. Okay. So we updated this. We set the recipient to the user that we have passed in here and update our components. So far, so good. So let's go on. So we clicked on our user. Now essentially our message area opens and we can write messages. We can already look at our messages. To send a message, we need, again, a simple execute, but this time from our mutation. And we say this is a send message mutation. We do an execute here. We essentially use our recipient that we have saved right here, and then just pass in the text. Okay, so essentially we just wrote a message. Now let's just update our message list equals to messages.add. And we just grab from the data here our send message and then the message that we get returned. It's again an iMessage because we defined that fragment there. We just update the state has changed. So how do we put in the real-time data? We put it up here. We essentially do chat client. And then we again subscribe. But this time we subscribe to our message stream that we get from the server. So we do a watch. In this instance, we don't care about cache first because we just want the live message stream. So we go with the default network only execution strategy here. So we subscribe to that, say result, and then just grab the message. Let me just put that in. So we take the message list that we have, the messages, messages, add, and we grab the result, grab the data, grab our message on there, and say state has changed. Okay. So if you look at the code we wrote, it's effectively not a lot. So let me just make it nice again.
Yeah, and it looks like you're publishing and subscribing to a lot of events in general, particularly in that first initialized setup.
Yes, I'm subscribing to events. There's one caveat here. So you have to get rid of so essentially these are sessions and you have to dispose them when you don't need the component anymore. Otherwise, you keep the subscription running. But that is pretty easy. You can just implement an iDisposable here. That's one way to do it. I don't care about that now. We also built a bit more integration into Razor, that you have something like they call in Angular the async pipelines, where you essentially can just put the observable into your components, and all this is handled magically. So if you know Angular, you know what I'm talking about. But this is still in the works. We are still experimenting a lot with the life cycles in Blazor. But at the moment, you could just dispose these components or these observables. Okay, so we have our chat client here. We can just refresh it. We get an error, and that's because We are using now subscriptions, but we haven't put in a socket connection. And this is pretty much also generated actually for you. So we have this chat client, we have the HTTP client, and what we essentially provide is a very easy way to handle socket connections. And that is, you go in here, say add socket client, and that mirrors the setup of the HTTP client. You can also hook in here middlewares to handle connection aborts, to put poly in, and stuff like that. In this instance, I'm cheating a bit with authentication since I'm just putting in the URI for the WebSocket connection, passing in the token as a URL parameter. This is not the fine way. And if you're on our Slack channel, I will always tell you to put the token actually on the message, but it's a lot more setup code you would need for that. So let's just stick with the easy task.
So this is one of those situations where this is good for the demo, but like don't do this in production.
Exactly. It's much better to put it on the message, because then you can also swap out the token once it's on the UI. It's not as easily.
Yeah.
Okay. So on the message, you can even have a refresh message for your token and stuff like that. But for the demo, it's actually pretty easy to set up. We can see it's running now. We have our middle area here. I can click on maybe. Oh, so you see my design skills are not the best. So I can click on any of these users here. Maybe write a message, hello bar. Send that message, get here hello bar. And actually you can try out if my subscription works here. Let me just grab my notes. Not that. Let's go to channel 9. So it's this URL. I can post that maybe even to the YouTube chat, and then you can more easily grab it. So let me put that over here.
Yeah, if you want to, you can give it to me and I'll drop it in the chat.
I already did it, but I can also give it to you as well if you want to put it on Twitch. I think I put it on YouTube. Yeah, you can already see that FTW is not from me, but hello. This is me. Hello, Michael from New Zealand. So hello, New Zealand. So you can see people are already sending into my debug session here, and that is pretty easy to put that together. And if so I haven't, because this is really new, the stuff we built around that. So we built over the next few days until the end of this month, we built out a more sophisticated demo that really shows off how to serialize your state. So how can you put your state, save your state on the disk, which is cool when you have Blazor for Windows. And also to do other things like writing local resolvers. Why local resolvers? Because with local resolvers, you can extend your schema right here on your client application, and then just say, okay, I need an extra field on my user or on my person entity from the server, but I want to fill it with data from my local state. Maybe I have some extra data on my storage, or I have some extra data that is coming over REST, and we will aggregate, essentially schema stitch on the client side for you, and you only have to work against our Strawberry Shake client. So everything, you can write GraphQL queries and actually fetch from your file system. So we will pimp this demo more, and we'll update you if you follow us on our GitHub page or on Slack.
That's awesome. And so we're pretty much at about time, but Michael, I want to say this has been a really great demo, man. Like we just spent an hour and a half talking about how we could work with some of the stuff in Blazor. I know we had some folks in the chat that were really interested in talking about some of the server-side aspects of Hot Chocolate. So I think we're gonna have you come back on again and talk about it. Also, you have been on .NET before, so if folks that are watching, if you head over to Channel 9 and you go to our on.NET show, Michael has about 3 or 4 videos talking about server-side
Yes.
or GraphQL and some of these types of things. So definitely recommend that you have it over there and check them out until we can get him to come back on again. But I think, why don't we end off with letting folks know, like what's the website for Hot Chocolate? Where could they go and learn about things and see things and reach out to you and that type of stuff?
Yeah, so the best thing to go to our page is GitHub. So head over to GitHub. If you like us, give us a star. All the contributors really love to see our star count growing. So it's kind of our reward. All the work is done in our free time, so that is a nice appreciation. So this is essentially the base where you can find all the source code. So all the source code to Strawberry Shake, what Strawberry Shake looks like. You can find how we built the source generator, everything in here. So there's nothing hidden, there's nothing proprietary, everything under a good license, the standard open source license from Microsoft. And we have a Slack channel, the Hot Chocolate Slack channel. We've linked to that on our GitHub page. And there is constantly, you can see there are already messages waiting for us. So there's a big community, 1,700 users talking about Hot Chocolate and Strawberry Shake. So join us. We love to have you.
Great. And then everything that you've shown today is in Hot Chocolate version 11 and above, right? So these are things that people can go out now and try out and use, and they're pretty good to go.
It's so what I've shown you is essentially Strawberry Shake preview 58. So it is this guys here, and essentially it gets started with the new Strawberry Shake code generation C# analyzer package. But have a look at my public speaking repository. So go on GitHub, and that's where you can fetch the demos. So it's Michael Staib public speaking, and there is a new Channel 9 live, and there is a demo 1 completed. This is the final example that we have here, and then you can essentially look at how I put that together with the current version 58 that is on the internet on NuGet.
Got it. And then I'm just pulling up the link now. I'm going to drop the link in the chat for folks to.
I can post them to you here.
There you go. So it should be in the chat now for folks that are on YouTube and Twitch that are watching us. Definitely feel free to go ahead and fork Michael's repo, check out the code, send him a pull request if you want, and and let us know how do you like working with GraphQL in ASP.NET. Let us know if there's anything that you'd like to see from a data perspective with Entity Framework, or even from an Open API perspective in terms of discoverability. Again, let us know for sure. So I guess with that being said, Michael, it's been great having you on, man. Every time you come on, I feel like your library just continues to grow, and there's always more stuff in here to check out. So, we're gonna have to try and get you on another time. So again, thank you for coming on. Really appreciate it.
Okay.
All right, everyone. Well, hey, thank you all for watching. We'll be back next week for another episode of On.NET Live. Next week, we're going to have Ryan on. He's going to be talking to us about Dapper. So that should be really cool. So if you're interested in building microservices and want to know how well Dapper works with .NET, make sure you tune in here. Same time next week, Thursday. So bye, everyone. Take care.